Hey guys, Mr. Backerberg here. In this video we're going to look at solving quadratic inequalities. So the process we're going to use to solve a quadratic inequality is as follows. Step number one, we are going to find critical numbers by taking our inequality and setting it equal to 0 and then solving. Then what we're going to do with those critical numbers is break up the set of real numbers into a bunch of different intervals. And then based on what we come up with our intervals, we're going to test each interval to see if it's positive or negative. So in this example, we're going to solve the quadratic inequality x squared minus x minus 12 is less than 0. So step number one said that we wanted to find our critical numbers by taking our inequality and setting it equal to 0. So I'm going to take my x squared minus x minus 12, and instead of saying that it's less than 0, I'm going to set it equal to 0 so that I can solve it. Now this one is factorable. As we look at this x squared, to multiply to x squared, we're going to need x and x. We need a pair of numbers that are going to add up to -1 in the middle here, but multiply to -12. So that's going to be -4 and +3. Then in order to solve these, what we can do is take each factor and set it equal to 0. So x minus 4 equals 0, and x plus 3 equals 0. To solve this first one, we'll need to add that 4 over to the other side, so we'll get x equals 4. And to solve our other factor, we'll have to subtract the 3 over, so we'll get x equals -3. So we've got critical numbers at 4 and at -3. So what we're going to do is use those critical numbers to help us set up some intervals. Now we're going to be using interval notation here, so we're going to be using either parentheses or square brackets. Here, our original inequality does not have the equals to line underneath it, so we will be using parentheses because our end values will not be included. When we're setting up our intervals, we want to make sure that we're covering every single number that's possible. So our first interval will always start at -infinity. And remember, infinities always get a parenthesis around them. And then this first interval is going to run until it hits your first critical number, so the smallest critical number. For us, that's -3. Then we're going to close up that interval with parentheses, again, because that end value is not included. Then as we open our next interval, we're going to open it where our last one ended. So our last interval ended at -3, so this interval is going to start at -3 and then go until we hit our next biggest critical number. So for us, that's 4. So our middle interval goes from -3 to 4, and again, parenthesis there because the end value is not included. And then because we closed that interval at 4, we're going to open our next interval at 4. We don't have any more critical numbers, meaning that this last interval is just going to run out to +infinity. So those are the 3 intervals based on the critical numbers that we've got. Now what we need to do is test each interval to see if it's positive or negative. So in order to do that, what we're going to do is pick a test value from each interval and plug it into our original expression here to see if we get a positive result or a negative result. So I'm going to start in this first interval. We need to pick a number that's between -infinity and -3. So something like -4 would work. So I'm going to go to my expression over here on the left hand side, and I'm going to plug in -4. So we have -4 squared minus -4 minus 12. So -4 squared is 16. This double negative in here turns positive, so that's going to turn into a +4 then with our minus 12. So 16 plus 4 is 20, minus 12 is 8. So we got a positive result here, meaning that this first interval is a positive interval. No matter what number we would have picked in here, we would always get a positive answer. Now we need to move on to our middle interval. We need to pick a number between -3 and +4. I'm going to use 0. So if I take 0 and plug it in for x, we'll get 0 squared minus 0 minus 12. Well, 0 squared is 0. Minus 0 is still 0. Minus 12 is -12. So because I got a negative answer here, that means that this interval is a negative interval. Then we need to go to our last interval and pick a test value, so something between 4 and infinity. So we could use 5. So I'm going to take 5 and plug it in for x. So 5 squared minus 5 minus 12. 5 squared is 25 minus 5 minus 12. So 25 minus 5 is 20, minus 12 is 8. We got a positive answer, meaning that this is a positive interval. So now we know what types of intervals we're dealing with. The first interval is a positive interval, the middle interval is negative, and the last interval is positive. As we look at our inequality, we want things that are less than 0, meaning we're going to want the negative intervals. So in this case, our solution is the interval that runs from -3 to 4, because that's the only negative interval. Taking a look at this example, we've got the inequality 2x squared plus 3x is greater than or equal to 20. Before we get started on this one, notice that we don't have 0 on the right-hand side. So what I want to do is I want to subtract that 20 over to the left-hand side before we do anything else. So we'll have 2x squared plus 3x minus 20 is greater than or equal to 0. Now, just like before, we're going to find our critical numbers by setting this equal to 0. So 2x squared plus 3x minus 20 equals 0. This one is factorable again. This is going to factor into 2x minus 5 and x plus 4. Then what we're going to do is find our critical numbers by setting each one of those factors equal to 0. So 2x minus 5 equals 0, and x plus 4 equals 0. So on this first one, we're going to have to add the 5 over to the other side and then divide by the 2. So we're going to get x equals 5 halves, which is the same as 2.5. Then for this other factor, we're going to subtract the 4 over to the other side, so we're going to get x equals -4. So we've got critical numbers at 2.5 and at -4. So we're going to use those critical numbers to help us set up our intervals. Remember, our first interval always starts at -infinity, and that gets a parenthesis around it. Then it'll go until we hit our smallest critical number. So here the smallest critical number is -4. Now if we pay attention to our inequality, this time we do have the equals to line underneath, meaning that these end values, these critical numbers, will be included. So the -4 is going to get a square bracket around it. We close that interval at -4, meaning that we want to open our next interval at the same value, -4. And then we're going to go until we hit our next critical number, which is at 2.5. Again, square bracket because the end value is included. We close that interval at 2.5, so we need to open our next interval at 2.5. We don't have any more critical numbers, so this last interval will run out to positive infinity, and that gets a parenthesis around it because infinity always gets parentheses. So now what we need to do is pick a test value from each interval and plug it in. And I'm going to plug it in right here after we've subtracted that 20 over to the other side. So the 2x squared plus 3x minus 20. So in this first interval, we need to pick a number between -infinity and -4. So I'm going to use -5. So I'm going to take that and plug that in for my x. So 2 times -5 squared plus 3 times -5 minus 20. When we simplify that all the way down, we should get 15 as our answer. So we got a positive answer, meaning that this is a positive interval. Now we need to pick a test value from our middle interval, so between -4 and positive 2.5. I'm going to use 0. So now we're going to take that 0 and plug it in for our x. When we simplify that one down, we should get -20 as our answer. So getting a negative answer means that this is a negative interval. And then lastly, we'll need to pick a test value between 2.5 and infinity. So maybe we'll use 3 on that one. So we're going to take that 3 and plug it in for our x. And when we simplify that one down, we should get 7 as our answer. So getting a positive answer means that this is a positive interval. So now to figure out the solution, we're going to look at our inequality. It says that we want things that are greater than or equal to 0. Well, greater than 0 means positive. So we're going to look at our positive intervals here. So we've got a positive interval that runs from negative infinity to negative 4. But we've also got a positive interval that runs from 2.5 to infinity. So the answer is both of those. And since it's both of those, we're going to use that union notation to show that we mean both of those intervals. In this example, we're going to look at solving a quadratic inequality graphically. So we've got the inequality x squared minus 4x plus 1 is greater than or equal to 0. We're going to use our calculator to graph this one out. So on my calculator, what I've done is I've taken that left-hand side of the inequality and typed it into my y equals screen. And we're going to get a picture of what this graph looks like. So I hit my graph button, and we get that parabola shape. What we want to find are the x-intercepts. So in order to do that, we're going to hit second trace. And remember, another name for an x-intercept is a 0. So we're going to pick option number 2. There's a couple of x-intercepts. We're going to have to find them separately. I'm going to start with this one on the left-hand side. It asks me for a left bound point, so that means I need to arrow left of where that x-intercept is happening. Hit enter. Then it asks me for a right bound point, so I arrow over to the right past the x-intercept and hit enter again. We can take a guess, but we don't need to. So our first x-intercept is at about 0.27. Then if we look at finding our other x-intercept, so I'm going to hit second trace again, and I'm going to use option number 2 again, finding another 0. So now we need to go over by the other x-intercept. And again, it asks me for a left bound point, so I want to make sure that I'm on the left-hand side of that x-intercept. Hit enter. Then it asks me for a right bound point, so I arrow to the right past the x-intercept. Hit enter. Again, we can take a guess, but we don't need to. We can just hit enter one more time. So this x-intercept is happening at about 3.73. Now we're looking for where our inequality was greater than 0. Graphically, greater than 0 means above the x-axis. So there's two places where this is happening. It's happening over here on the left-hand side where this chunk of the parabola is above the x-axis. Not in the middle because that's below the x-axis, but then again over here on the right-hand side, that part is above the x-axis. So that's also part of the solution. So here are our two x-intercepts. We said that the solution was the stuff on the left-hand side where that piece of the parabola was above the x-axis. We couldn't see where that started, so we're assuming that it started at negative infinity and went until we hit that first critical number, or that first x-intercept at 0.27. This end value is included, so it gets a square bracket around it. We're going to have two separate intervals, so we're going to use our union notation. And then we're going to have another interval that started at 3.73 included, so it gets a square bracket. And that one, we couldn't see an ending point to that, so we're assuming that that runs out to positive infinity. So these two intervals are the solution to the inequality, based on what we saw graphically. Now it is possible for a quadratic inequality to have no solution. So as we look at this one, we've got x squared plus 2x plus 2 is less than 0. I'm going to use my calculator to show that this one has no solution. So I've already got the left-hand side of my inequality typed into my calculator. I am going to graph it. Now we get this parabola shape. Our inequality said that we were looking for where this was less than 0. And less than 0 would mean below the x-axis. We can see that there is no portion of our graph that's below the x-axis, so this inequality is going to have no solution to it because it's never negative. That's going to be it for this video. Thanks for watching.